Good day, everyone. So today we are going to report about photoelectronics, lasers, and fiber optics. So what is photoelectronics? In today's world of motion, photoelectronic sensing plays a large role in the high-speed detection. The photo eye using light, visible or infrared, can discover distance, the presence or the absence of any object orientation, color, and the lack of color. What is laser? A laser produces a very narrow beam of light that is useful in many technologies and instruments. The letter in the word laser stands for light amplification by stimulated emission of radiation. Lastly, what is fiber optics? Fiber optics or optical fiber refers to a technology that transmits information as light pulls along a glass or plastic fiber. Here are subtopics for our report today. So number 1, analysis of light. Number 2, industrial photoelectronics devices. Number 3, optoelectronic devices. Number 4, industrial laser application. Number 5, fiber optics. So first, what is analysis of light? Light is a form of energy produced by a light source. Light is made of photons that travel very fast. Photons of light behaves like both waves and particles. Two main kinds of light sources. First one is the incandescent sources. Use heat to produce light. Nearly all solids, liquids, and gases will start to glow with a dull red color once they reach a temperature of about 525 degrees Celsius. Next one is the luminescent sources are normally cooler and can produce biochemical reactions such as in glow stick or glowworm. Light travels much faster than the sound because light travels at a speed of 2,099 and 99 7,992 7,902 and 458 meter per second. That's nearly 300,000 kilometer per second. The distance around the Earth is 40,000 kilometers, so in 1 second, the light could travel 7.5 times around the world. Sound only travels at about 330 meter per second through the air, so the light is nearly a million times faster than sound. Light travels in straight line. Once light has been produced, it it will keep traveling in a straight line until it hits something else. Why do we have shadows? Shadows are evidence of light traveling in straight lines. An object blocks the light so that it can't reach the surface where we see shadows. Light fills up all of this space before it hits the object. The whole region between the object and the surface is the shadow. So here is the graph. So the graph shows that the wave can be described by its length, height or amplitude, and frequency. So models of light. The debate of whether the light is made of waves or particles has been going for hundreds of years. Sir Isaac Newton thought that shadows prove that light was made of particles, but there is a lot of evidence that light is made of waves. On the picture, we can see the prism. So what is prism? When white light shines through the prism, each color refracts slightly more than red light. A prism can be used to show the 7 colors of the spectrum that make up white light. Light as waves. Rainbows and prisms can split with white light up into different colors. Experiments can be used to show that each of these colors has a different wavelength. Light as a particle. In 1905, Albert Einstein proposed that light is made of billion small packets of energy that now we call photons. Photons have no mass, but each photons have a specific amount of energy that depends on the frequency, number of vibration per second. Each photons still have a wavelength. Photons have more energy. The photoelectric effect. The photoelectric effect is when light can cause electron to jump out of a metal. The experiments confirm that light is made of massless particles called photons. So let's proceed to number 2, photoelectric devices. a device which gives an electrical signal in a response to visible, infrared, or ultraviolet radiation. They are often used in systems which sense objects or encoded data by a chance in transmitted or reflected light. Photoelectric devices, transducers are devices capable of converting light energy to electrical energy. In this respect, only a limited number of photoelectronic components comply with such a definition, that is, photovoltaic devices which specifically generate electricity when light falls on them. Photoconductive devices. One thing all photoconductive devices have in common is that they are basically diodes. Even the phototransistor that combines the photoconductivity properties of photodiode with amplification properties of a transistor, except that the diode part is a photoelectric device. Next is photovoltaic devices. A photovoltaic devices, on the other hand, works like a battery and is generally called a cell or photocell. This is the type used in self-powered light meters. Like batteries, they can be connected in series to generate a higher voltage, but still normally in a low voltage range, or in a parallel to generate a higher current in the low current range. It is also capable of being connected in series and or parallel. A multiple cell arrangement is called a solar battery. So in photoelectric devices, you can work out the resistor value in the meter range required in this way. In strong average sunlight, you can expect the cell that generates about 500 millivolts signal thus has to develop a current of 10 milliamperes. Through the meter for full-scale deflection from Ohm's law, corresponding circuit resistance required is R is equals to volts over amps. So this is equals to 500 times 10 raised to negative 3 all over times 10 raised to negative 3. So equals to 50 ohms. So in the graph, is an alternative wiring scheme for radiometer using a meter with high internal resistance. Making a solar battery. A solar battery is a true transducer which converts solar energy directly into electrical energy just like a battery. Its effectiveness as a battery depends on the strength of sunlight present and the number of arrangement of the cell used. So making a solar battery, so starting point at the design of a solar battery is the voltage and the current required. We already have 0.5 volts as a typical cell voltage in average sunlight. Thus, to generate a voltage of V, you need 2 times V cells connected in series. To generate 3 volts, you need 2 times 3 equals to 6 cells. So the picture shows the series connection of photovoltaic cells results in a higher voltages that can obtain with a single cell. The short circuit current of a typical solar cell is 5 milliamperes, corresponding to a nominal cell resistance of 500 over 5 equals to 100. With an external load, we can thus anticipate the current I to be I equals to 500 all over 100 plus R milliampere, where R is the external load resistance. Thus, for a 100 external load resistance, I equals to 100 all over 100 plus 100 milliamps is equals to 2.5 milliamps. Suppose we want to design a solar battery to work at 3 volts device that has a load resistance of 25 ohms, and you need to have a 12 milliamps current flowing through it to work properly. To generate a 3 volts, we need 6 cells connected in series, but the current through an external load of R equals to 50 ohm will only be I equals to 500 all over 100 plus 25 milliamps, and that is equals to 4 milliamps. So in the picture, you can see a series parallel of series parallel array of photovoltaic cells for obtaining at 3 volts at 12 milliamps. For a maximum effect, such a battery array should be mounted to be a point along the meridian or due south and tilted away from the zenith at an angle of approximately the local latitude. This is, of course, only possible with a fixed installation. So as you can see in the picture, this is the optimum array positioning of a solar battery array. The array should face due south and be slanted from the zenith approximately the local latitude. Other photovoltaic cells. Photovoltaic cells of the type used in the light meters and the other low current devices consist of basically of a thin film of selenium silicon deposited on a steel or a copper plate. So in the picture, a light meter for measuring low levels of illumination. Other photovoltaic cells work in the following way. Light falling sa photosensitive surface of such cells has the effect of liberating electrons in the boundary layer of the sandwich construction, which results that if connected to an external circuit, an electric current will flow in that circuit. Photoelectric or photovoltaic effect used in photodiode includes solar cells, phototransistors, photomultipliers, optoisolators, integrated optical circuits, OIC elements, photoconductivity used in photoresistors, photoconductive camera tubes, charge-coupled imaging devices, stimulated emission used in injection laser diodes, quantum cascade lasers. Photoconductive cells. Photoconductive cells are quite different in their work properties, for they need to be supplied with an external source of electricity. The effort of varying the level of illumination falling on the cell is to give its variable electrical resistance, the effective resistance changing in proportion to light level. Photodiodes. If any semiconductor diodes reverse bias in the junction illuminated, the reverse current flow will vary the proportion to the amount of light. This effect is utilized in the photodiode, which has a very clear window through which light can fall on one side of the crystal and across the junction of the p-n zones. Phototransistors. The phototransistors is much more sensitive than the photodiode to changes in level of illumination, thus making a better device where fairly small changes of levels of illumination are present and must be detected. It works both devices and an amplifier of the current generated by incident light. Annunciator photorelay. The circuit shown employs a conventional photoconductive cells with a straightforward amplification, giving a simple design, again with a minimum of components. Virtually any type of relay can be used with a coil resistance between 1 ohm to 10 ohm that can pull in about 3 milliamps or less. Annunciation relay with hold. The circuit just described can, with slightly modification, be made to work with a hold function. Extra sensitive annunciator. The addition of a second stage of transistor amplification to the type of circuit already described produces a circuit with extreme sensitivity to light changes. Scanning techniques. Number 1, through scan. Number 2, reflective scan. Number 3, reflective scan. Number 4, specular scan. Number 5, diffuse scan. Number 6, color differentiation. Number 7, sensitivity adjustment. So number 1, through scan. In through scan, the light source and the photo receiver are positioned opposite each other. So light from the sensor shines directly at the sensor. Reflective scan. In reflective scan, the light source and the photoreceiver are placed on the same side of the object detected. Retroreflective scan, the source and the sensor are in the same enclosure. A tri-cornered reflector makes alignment less critical than a flat reflector. Specular scan. The specular scan technique employs a very shiny surface such as a rolled or polished metal, shiny plastic, or a mirror to reflect the light to the sensors. Next is diffuse scan. Non-shiny surface such as craft paper, rubber, and cork reflect only a smart amount of light directly. Color differentiation. In distinguishing color is the registration mark detection. Contrast is the key. High or dark color on light or vice versa provides the best signal ratio and control reliability. And lights and sensitivity adjustment. Most photoelectronic controls have sensitivity adjustment to determine the light level at which the control will respond.
Optoelectronic devices. It is communication between optics and electronics which includes the study, design, and manufacture of hardware device that converts electrical energy into light and light into energy through semiconductor. Photoelectronics or optronics is a study and application of electronic devices and systems that find, detect, and control light, usually considered a subfield of photonics. In this context, light often includes invisible forms of radiation such as gamma rays, X-rays, ultraviolet, and infrared. In addition to visible light, optoelectronics devices are electrical to optical or optical to electrical transducers or instruments that use such as device in their operation. Light emitting diode. Light emitting diodes is p-n semiconductor diode in which the recombination of electrons and holes yields a protons. Optical fibers. It is a plastic and transparent fiber made of plastic or glass. Laser diodes is a source of highly monochromatic, coherent, and directional light. Application of optoelectronic devices. The solar cells. Solar cells measurement system Arduino-based solar light street light, solar power charge controller, sun tracking solar panels, optical fibers, telecommunication, sensors, fiber lasers, biomedicals. LEDs or propeller display of message by virtual LEDs. LEDs based automatic emergency light. Mains operated LED lights displayed of dial telephone numbers on a 7-segment display. Solar power LED street lights with auto intensity control. Laser diodes, fiber optic communication, optical memories, military application, CD players, surgical procedures. Industrial laser application. Laser materials processing is done on various materials such as metal, alloys, ceramic, glass, polymer materials. New manufacturing process is based on laser as tool. Laser processing provides a competitive advantage over traditional methods of industrial fabrications. High power pulse, continuous wave or both forms of layers beams are used. Novel applications using lasers are still emerging every day. Laser interaction with materials. Two types of laser processes. And thermal processing, photoelectronic, photochemical, and photophysical. Thermal processing, heating, melting, and vaporation. When a laser beam is incident on a metal or other material, the radiation energy is absorbed and the material is heat up. Depending on the amount of absorbed energy and interaction time, the material is even melted or vaporized once the surface of the materials absorbs energy. The material starts to melt and then vaporized once the surface of materials absorb energy. The material starts to melt and then vaporized. Processing count. A high intensity of radiation, the vapor will be ionized to produce plasma. Plasma layer performed between the laser and workpiece prevents the laser beam from reaching the workpiece. The thermal processing are utilized in various materials processing application. Heating, hardening, surface modification, melting, welding, alloying, cutting, rapid prototyping, vaporizing, drilling, marketing, deposition, surface cleaning. How hot is actual the laser beam? Heat is random motion of matter particles, atomic or molecular particles. However, the laser beam itself is not made of matter but of protons, the so-called light particles which have no mass. That a laser beam can have no temperature depending on the amount of absorbed energy and interaction of time. Materials is even melted or vaporized. Laser cutting. Cutting of metal sheets, foil, or glasses provides high edge quality. Laser cutting is highly focusable to about 25 microns. Computer numerical control or CNC programmed cutting machines. Melting fusion mechanism materials is expelled by the kinetic energy of assist gas. The efficiency of laser cutting can be cutting increasing by making use of gas jet coaxial with the laser. Laser drilling. A series of pulses is fired at fixed location on the workpiece. Usually powerful light pulse of duration 10 raised to negative 4 to 10 raised to negative 6 seconds is used. The material subject to laser drilling is vaporized and melted layer by layer until the drill holes are connected. The radiation becomes trapped in the keyhole, including plasma formation use of assist gas like 0O2. Conventional drilling methods: mechanical drilling, mechanical punching, electrochemical machining, electro discharge machining, laser welding. Metal sheets are welded together by so-called heat conductive welding. The, las- the laser beam hits the edge of the two plates to their melting points and cause them to fuse together where they are in contact. Laser beams are scanned over the surface of the mating parts along the common joint. Widely used in automobile, electronics, jewelry, engineering, manufacturing industries. Conventional welding methods: resistance welding, ultrasonic welding, soldering, brazing. Surface cleaning. A laser cleaning is a non-contact process used to remove rust, paint, oxide, and contaminants from the metal surfaces. The physical reaction during the surface cleaning of the metal surface oxide is also known as ablation. Laser ablation occurs when a material layer or coating is removed with the laser beam. Vaporize the undesired material into fumes by heating effective or laser beam. The energy transferred by the laser beams must be above the ablation thresholds. A laser cleaning requires a pulse fiber laser, typical 500 watts or more. Surface cleaning application. Old painting remove, fine finish surface, rust and oxide removing, welding, pre and post treatments, removing oil from the surface of materials, removing the burnt rubber residue from entire molds. Other application: hardening of fer- ferrous materials, stainless steels, titaniums, alloys, labeling and marketing, engraving, serial number barcodes, laser deposition of thin film, photolithography, electronic components, PCB fabrication, optical communications. Military. Laser safety. Laser safety is extremely important to both the developer and the user community. We have to address the both real and perceived hazards. Laser safety issues. Laser point 3 microvolts rather bright could quickly damage by the retina, but blinking reflex helps. Small ND YAG lasers 100 microvolts invisible no blinking reflexes. Rather dangerous for the eyes. Larger ND YAG lasers or 10 watts burn skins into clothes. Small NG-YAG lasers for zero switch pulses. Very hazardous even for small average output power. Industrial high power ND, YAG or CO2 laser 1 to 10 kilowatts. For welding, non-beneficial for skin and eyes. Laser warning symbols. International laser warning symbols. As you can see in this picture, you can see the international laser warning labels. Advantages. Ac- Accuracy and precision, non-contact technique, rapid processing, multifunctional machines, flexible beam guiding through optical fibers. Beam can be focused to very small to large areas, compatible compatible with computer aid manufacturing or CAM system. Absence of tool wear and tear. Current research. Fiber lasers for manufacturing building more faster ultra-fast lasers, efficient cooling mechanism, compact chillers, fiber, coupled high-power diode laser based on a gas. Optimization of materials absorption efficiency, tunable lasers, artificial intelligence or AI to create smart lasers that understand the materials being processed. Optical fiber. In Commonwealth English is flexible, transparent fiber made by drawing glass, silica or plastic to a diameters slightly thicker than that of a human hair. The optical fiber. An optical fiber is cylindrical, dielectric, waveguide, non-conducting waveguide that transmit light along its axis through the process of total internal refraction. The fiber consists of a core surrounded by a cladding layer, both of which are made by dielectric materials. To confine the optical signal into core, the refractive index of a core must be greater than that of a cladding. The boundary between the core and cladding may either be abrupt in step index fiber or gradual in graded index fiber. Light can be fed into optical fibers using laser or LEDs. So here are the principle of operation. As you can see, a step index finger and the graded index finger. Yeah. The fiber cable. Fiber cable do not conduct electricity, which makes fiber useful for protecting communications equipment in a high voltage environment such as power generation facilities or application prone to lighting strikes. The electrical isolation also prevents problem with ground loops because there is no electricity in optical cables that could potentially generate sparks. They can be used in environments where explosive fumes are present. Wiretapping, in this case fiber taping, is more difficult compared to electrical connections. What are the optical fiber are used? To transmit light between the two ends of the fiber and find wide usage in fiber optic communications. Fiber are used instead of metal wires because signal travel along them with less loss. for illumination and imaging, and are often wrapped in bundles so they may be used to carry light into or out of the confined space, as in the case of fiber scope for fiber optic sensors and fiber lasers. This is the end of our presentation.